Hello everyone. This video will be on the 3.18 section of the IB/AA curriculum. Please pause the video for a second to look at the concepts and contents for this section. There are no formulae. One sentence that summarizes this section is lines and planes can be related in multiple ways. First of all, welcome to the last video of this topic. It was a long topic and especially more difficult for the HL students. Let's pat ourselves on the back for the hard work. This topic is another extremely difficult topic. You must have a deep understanding of the concepts and the content to solve questions from this section. So keep your eyes and ears open to stay on the point. Alright, so let's get into business. The first part of this video will be on the intersection of lines and planes. Just like the 3.15 section, a line and a plane could be intersecting each other, or be parallel to each other, or coincide with each other. Let's first look at the intersection. Just like the two lines intersecting, we can put the equations to be equal to each other to find the point of intersection. And let's put L equal to 3, 2, 1 plus lambda and 1, 0, 2. And then let's put the plane P equals to 1, 2, 0 plus, let's say, A 0 to negative 1, B plus B, 5, 0, negative 1. And we can use the parametric equations for both, and we know that the intersection point means that the x, y, and z are all equal. In this case, I get three equations with three variables. I go 3 plus lambda equals to 1 plus 5b, 2 equals to 2 equals to 2 plus 2a, and lastly 1 plus 2 lambda is equal to 0 plus negative a plus negative b. Then we get three equations. Lambda minus 5b is equal to negative 2, and negative 2a equals 0, and 2 lambda plus a plus b is equal to negative 1. So at this point, we can use the system equations to solve this question. Right. But this sounds a bit tedious, doesn't it? Surely this is possible, but it may take a long time. So in this case, we can use the Cartesian equation of the plane. So let's change this equation of the vector equation of the plane into the Cartesian equation, which turns out to be 2x plus 5y minus 2z equals 12. Then what we can do is we can simply substitute the x and y and z with the parametric equations of the line and find the lambda that works. So let's do that. So I know from the line equation, x is 3 plus lambda. So let's say 2, 3 plus lambda, plus 5, 2, minus 2, 1 plus 2 lambda, equals 12. Notice how I put it, x and y, z, from the line equation into the Cartesian equation of the plane. Then we can solve this. 6 plus 2 lambda plus 10 minus 2 minus 4 lambda equals 12. Then negative 2 lambda is equal to 12 minus 6 minus 10 plus 2. 14 minus 6 minus 10, negative 2. And we get lambda is equal to 1. So now we put the lambda back into the line equation to get the point. So then, because lambda is 1, then our point will be 4, 2, and 3. Alright, so we found the point of intersection between a line and a plane. And then can we find the angle between the line and the plane? For this one, we can use the normal vector of the plane to help us find that. And we can draw the situation like this. So if I have a plane like that, and then I have a line that goes through it. Then we're looking at the angle between the line and the plane. Okay, and if you draw the situation like this, and we notice how if we find the angle between the normal vector and the direction vector, so the normal vector will be something like that. Normal vector, and let's say the direction vector is here. Let's say B. And if you find the angle between the normal vector and the direction vector, let's say that's psi. Then to find the angle between the line and the plane, theta, then we'd simply theta is equal to 90 minus psi, 90 degrees minus psi. So if you do that, so from the Cartesian equation of the plane, I know that the normal vector is 2, 5, and -2, and the direction vector of the line is 1, 0, 2. So if you find the angle between those two vectors, we can use the formula, and it turns out that angle between the direction vector of the line and the normal vector of the plane turns out to be 8.96 degrees. Then from that, we know that the theta, which is the angle between the line and the plane, is 81.04 degrees. So we know that the answer is 81.04 degrees. What if we have two planes? If we have two planes, we don't have the point of intersection anymore. We instead have the line of intersection. How will we find that? Well, let's talk about the fundamental part here. A line requires two informations, a point and a direction. Let's first find the direction vector. If we have two planes, we can find the normal vector for each plane. And what would happen if we take the vector product of them? It'll be parallel to the line of intersection, wouldn't it? So we are using the fact that the vector product of two vectors produces a vector that is perpendicular to both vectors, then which is parallel to both of the planes. Now we have to find the point of intersection. And we can choose to find a point by simply setting one of the x and y and z as 0. So to try this example, let's use the plane equation from above. 2x plus 5y minus 2z equals 12. And let's introduce another equation, another plane. X minus y minus z equals 1. Right, so if I visualize the two planes intersecting, probably it's going to be something like that, and that, and you can see how there must be a line of intersection through these two planes. So normal vector would be like that, and another normal vector would be something like that, and the vector product of the two normal vectors looks like that, which is parallel to the line of intersection, as you can see. Right, so after we find the vector product of the two normal vectors, which can be found like 2, 5, -2 times 1, -1, and -1. I'm not going to do it right now. You can do it on your own time. So that's going to be my direction vector. So what about the point? Well, I think for our question, we can try to set z as 0. Right? So basically I have 2x plus 5y equals 12 and x minus y equals 1. Right? Because that is z, we're just putting a z as 0. Then this is a simpler equation to solve because we only have two variables and two equations. So I think I can subtract both sides by subtract the first equation. So from the first equation, I'll subtract the second equation twice. So then it becomes 2x minus 2x, so it's 0. And then 5y minus 2y, 5y plus 2y, so it's plus 7y equals 12 minus 2, so 10. Then I know that y has to be 10 over 7. And then from that, I can tell that x has to be 17 over 7. So the point becomes 17 over 7, 10 over 7, and 0. Now I have a point, or the position vector, and the direction vector, which means I can find the line of equation. So the line becomes L equals 17 over 7, 10 over 7, and 0, plus the direction vector, whatever that is. Okay. So finding the angle between the two planes are actually a lot simpler, and we simply have to find the angle between the normal vectors. So if I visualize that, so this time I'm going to just draw the plane as if we're looking at it from a side view. So here's like plane 1 and the plane 2. Okay, and then what I'm going to do is I'm going to find the normal vector of the plane 1, and also I'm going to find the normal vector of the plane 2. Then, if we find the angle between the two normal vectors, let's say this is theta, and from that we can conclude that the angle between the two planes is also theta. You can try to prove why this is true on your own time. Right, lastly, what if you have three planes? The three planes could have a point of intersection, a line of intersection, or no point or line of intersections. The solution is quite simple. We simply put three Cartesian equations into a system of equations. So let's put these two, and then I'll just randomly put one more line of Cartesian equation of a plane. So we have 2x plus 5y minus 2z equals 12, x minus y minus z equals 1, and let's just simply put something like 3x plus 5y equals 10, something like that. Okay, now we have three equations with three variables. So this is quite complicated, but this is a system of equations where we can solve for the x, y, and z. And from that, we can tell the point of intersection of three planes. Okay? Sometimes you'll get the line of intersection if one of the variables don't matter, but that happens too. Okay? Visually, if I have three planes intersecting, I'll have something like this: first plane, and the second plane, and let's say a third plane, like that. It's hard to imagine, but you know what I mean? Yeah, there must be a point of intersection. Okay? Right. So now, let's try one last question to finish off. And if you understand the solution for this question as well, you may be able to solve any questions regarding this topic. Let's try to find the shortest distance between a point and a plane, given that the point is not on the plane. Perhaps we can use a plane from above, x minus y minus z equals 1. And the point we'll use will be, let's say point A is 2, 2, and 1. And if I visualize this is my plane, and we have a point here. First thing we need to do is find a line between the plane and the point. Then we can find the point of intersection of the line and the plane, and find the length to find the distance. The shortest distance tells me that the direction vector should be perpendicular to the plane, and we already know from the normal vector, which is 1, -1, and -1. So it's going to be like something like that, where the line is perpendicular to the plane. Then we can find the point of intersection of the line and the plane, and find the length. Right. So now we know the line equation, and let's find a point of intersection. And because we know that the line is 2, 2, 1 plus lambda, and 1, -1, and -1, and simply we can put this line equation into the Cartesian equation of the plane to find the point of intersection. And it turns out to be that the point is 8 over 3, 4 over 3, and 1 over 3. And from this fact, we can find And from this fact, we can find the distance between the 2 points using the formula. And it turns out that the distance is 1.15. Okay. I hope you enjoyed this video, and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.